Simplify, assume the variables represent positive values, so no absolute values are needed. So that just means that we're not going to have to worry about these D and E's, okay, if our x's represented negative numbers. Okay, we're just going to assume that the x's and y's are all positive bases, so we don't have to worry about that. Okay, all right, so square root of 36x squared. You are going to take the square root of 36, which I know you know is 6, right? So it's kind of like we can split this up, right? Okay, so this is 6, and then the square root of x squared, remember that these are opposite operations. They undo each other. So the square root of x squared is x, right? Okay, all right, beautiful. Okay, all right, let's go to the next one. Square root of 144, x to the 10th, y 18th. So I want you to see what's happening here, okay? The square root of 144, that's 12. The square root of x to the 10th, okay, so let's look at this. So there are 10 x's here, aren't there? I'm going to write them all out because I want you to visualize this. Although some of you will not need to do this, but some of you will, right? See how there's 10 x's? Every 2 x's are a perfect square, right? Every 2 x's. So this is a perfect square, and 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 this is a perfect square. So do you see how there's the square root of x10? The square root of this x squared is 1x, right? So if we take the square root of all of these, I know this seems weird, but some students have trouble with this concept, okay? So if you take the square root of x squared, that's an x. And then you have another one here, and another x here, and another x here, and another x here. And when you multiply all of these, you know from your product rule, that's x to the 5th. So the square root of x to the 10th is x to the 5th, right? Now, do you remember that when we square a power like this, that we multiply exponents? So see how, just to check our answers, that x to the 5th squared, that would give us x to the 10th. So again, square root of x to the 10th is x to the 5th. And you can see it here all splayed out. Okay, look at this, y 18. So now we have how many of these little pairs if we had 18 y's? Well, if you said there's 9 little pairs, then you're right. So the square root of y 18 is y to the 9th, right? All right, so what's the final answer here? 12. Square root of 144 is 12. Square root of x to the 10th is x to the 5th. Square root of y to the 18th is y to the 9th. Okay? All right, so that's the answer. All right, look at this one. Cube root of a negative 125. X to the 6th, y to the 9th, c cubed. All right, so cube root of negative 125. What do we cube to get a negative 125? If you said negative 5, you're right. So we've used 125 a lot in our factoring of cubes, right? Okay, now we need the cube root of x to the 6th. So we have 6 x's, right? X to the 6th. Trying to do cube root of x to the 6th. So there's 6 x's. Now we're looking for groups of 3's, right? Cubes are x times x times. These are the perfect cubes, right? The cube root, we're looking for, the groups have to be cubes, so they have to be 3 of each thing, right? So we have a group here of x's, 3 x's, and another group of 3 x's. So x times x is x squared. All right, cube root of y to the 9th. Okay, so now we have 9 y's, right? 9 y's. And we're looking for groups of 3, right? And so cube root will be y cubed. See, because we have this y and that y and that y. We multiply them together. Y times y times y. All right, and then the cube root of z cubed is just z. That's a perfect cube, right? Okay. So here's our answer. Oops, sorry about that, but don't forget our negative sign. All right. Go to the next one. Cube root of 64, x to the 21, y to the 15. So cube root of 64, that's a perfect cube. That's 4 cubed, right? So the cube root of 64 is 4. Okay, but now we need the cube root of x to the 21. Do you remember that we're making groups of 3s? We have 21 x's. 21 x's. Think about that. 21 x's. And we have to group them in groups of 3. So how many groups of 3 would we have? Well, if you said 7, you're right. So x to the 7th is the cube root of x to the 21. All right, look at the y15. There's 15 y's. We need to group them in groups of 3. The index tells you the groups, right? Okay. And so how many groups, if I have 15 y's, how many groups of 3 can I make? 5 of them, so y to the 5th. So if you think we're doing a division, yeah, I think, yeah, that's kind of what we're doing, isn't it? Okay, let's go to the next one. 4th root of 81. By the way, with these videos, if you ever need to pause me and rewind, go for it, right? Okay, so 4th root of 81. So 81. So 4th root of 81. Do you remember what it is? Okay, but if you don't, let's go back over here to our calculator. And remember under math, so we're going to put the index, put the 4 for the index, at least on my calculator. Use the math menu. It's number 5. And then I'm going to put in 81. And then I'm going to hit enter. Boom, it's 3. Yep, it sure is, because 3 times 3 times 3 times 3, 4 3's multiplied to an 81. So this is a 3. Okay, now we have 8 x's. But this time our group size is 4's. How many groups do I have? Well, I have 2 groups of 4. So my 4th root is x squared, right? Okay, we have 12 y's. How many groups of 4 y's can I make with 12 y's? I can make 3 groups. So the 4th root is y cubed. Okay, beautiful. Let's go to the next one. 5th root of negative 32. What number do we multiply times itself 5 times to get a negative 32? Right? So if you can do this in your heads, I know you can. And yep, it's negative 2. So negative 2. Okay, so now my groups have to be of 5. So I have 5 x's. The 5th root of x to the 5th is 1. For every 5 x's that are under the radical, in the radicand, when you take the 5th root, 1x comes out, right? Okay, I have 20 y's. I need to group them in groups of 5 y's, right? So how many groups can I make out of 20? I can make 4. So the 5th root of y to the 20th is y to the 4th.